let's take a look. We're going to use specific exponential models. Yesterday we talked about this is the general form of an exponential model. What does y always represent in these exponential models? This is math class. Most things represent. I was going for future value. Okay. If these are dogs, it's population of dogs. If it's money, it's money in a bank account. A represents what? The initial value. Okay. B represents my growth or decay factor. Okay. That lets me know where this is exponential growth or exponential decay. X, that variable, which is our exponent in all of our models, will represent what? Time. Okay. Okay. So that is it. Now today we're going to specifically talk about exponential models that deal with money being invested. So compound interest. So I'm going to just do this right quick just so you can see where the formula comes from, but you won't be tested over this part. But just think about it. If you have $1,000 in a bank account and it earns 10% interest every year, okay, at the end of the first year, how much interest did you earn? $100, which is how many percent? 10%. So you end up with 110% of what you started with, right? Everyone understand that? Okay. How do I convert percent to decimal? Yeah, so 110%. I don't know how you learned it, but this is the decimal. It goes shopping, 2 places to the left. So this is 1.1. That means 110%. Okay. You'll need that skill today of converting percent to decimal. So if I started with $1,000, at the end of 1 year, I'm going to have $1,000 times 1.1. Okay. I'm going to have $1,100. Okay. That's what I have at the end of year 1. I'm going to skip the interest earned thing over there. So what happens at the end of year 2? I calculate my interest based on what? I don't start over. I end up with 100% of what? 100%, 110% of this value. Okay. So the next year, I'm going to have this. I'm going to calculate that interest twice. Okay. So I get, after the end of the first year, I have 110% of what I started with. The next year, I will have 110% of whatever I had at the end of year 1. What happens at the end of year 3? Yeah. I calculated that interest how many times? 3 times. Okay, so this interest is being compounded. It's in an exponential way. Okay, after the end of 4 years, I'm going to have $1,000 that I started with, but I'm going to calculate 110% of it how many times? 4 times, and so forth. Okay, so when you get to 5 years, you started with $1,000, you end up with $1,000, and you calculate 110% 5 times. Okay. So that's how we get compound interest. That's one of the powers of saving your money early, because over time, the power of money to grow. So there are 2 formulas we need to hit today. The first one is this compound interest formula. This formula will be on your quiz. You do not need to memorize it, but you need to know how to work with it. So the formula will be there. Explanations and definitions will not be there. That's the knowledge you will bring to the assessment. Okay. If I look at this, what do you think A represents? Yeah, the future value. Okay. What do you think P represents? Right, my initial value. Another word for initial value when I'm talking about money starts with a P. It's my principal. Okay. R means what? And you think in this case? It's the rate. Okay, so this is the rate. Basically, it's your interest rate. Yeah, so it's interest rate. And one big thing you need to know how to do here is you need to be able to convert from percent to decimal, okay? If I tell you the interest rate is 5.4%, that's 0.054 in decimals. You got to be able to go from percent to decimal in all of these problems. N is the number of times that the interest is compounded or calculated, that's just another word for that, per year. Okay? The number of times I will compound the interest in a year. What do you think T represents? Time in years, okay? So you'll have this formula. It's just as easy as figuring out what the values are, plugging them in, putting it into your calculator. Now, N is how often I compound the interest. If I were to compound the interest daily, how many times a year would I be compounding interest? 365. If I compound the interest weekly, how many times will I be compounding the interest in a year? 52. Monthly, 12. Quarterly, 4 times. Semi-annually, 2. Annually, 1. Okay? So when you have a problem and it says the interest is compounded monthly, N will be 12. If it's compounded yearly, N will be 1. Okay? So these are just common units of time across a year. So you'll look for those clues in your problem. So let's move on to a problem. A bank offers 3.5% for their monthly savings accounts. That would be a huge interest rate for a savings account today. It's probably more like 0.035 if you get interest today. Write the specific equation that will model this. So we just learned that equation a minute ago. A equal P 1 plus R over N to the NT. And again, that formula will be given to you on your test. You just need to know how to apply this, okay? Now, let's write down everything we know. We're trying to answer this question, okay? So, what is 3.5? Which variable would that be? That's my rate. So my rate is 3.5%. Converted to decimal, that's 0.035, okay? That's the number I'm going to use. That is my rate, 0.035. Everyone see how I converted 3.5 from percent to decimal? Move it over 2 places to the left, okay? How much money would you have in 7 years? What is 7 in this equation? Yeah, so T is equal to 7, okay? How much money would you have if you invested $4,000 today? Which of these variables is 4,000? P, okay? P is equal to 4,000, okay? And then N. How often is this compounded? How often? It's compounded. Look at the word that goes right after the word compounded. It's compounded monthly. How many times will it be compounded in a year? 12. N is equal to 12. Okay? That's everything I need to figure out what this answer is. So the amount is equal to the principal, $4,000, 1 plus 0.035 over 12, all of that raised to the 12 times 7. This is where you should be thankful for a calculator that lets you input everything just like it's written. So I'm going to go straight to my calculator, put in that exactly. So 4,000 times 1 plus 0.035 divided by 12. Go outside the parentheses. Raise all of that to the 12, what is it, times 7? Times 7 power, and I get 5108.66. This is time, money, dollars, monkeys. What is this? It's not monkeys. This is what? Money. It sounds like monkeys. 5108.66. So it tells me that I will have 51, what did I say? 5108? 5108.66 in 7 years. Okay, so in that investment, I start with $4,000. At the end of 7 years, I have 5108.66. Okay, pretty straightforward. Okay, now the next question starts with the word how long. Somebody tell me what concept. Pardon me? Okay. I'll leave it like right there. The next question starts with how long. That means I'm solving for what kind of concept? Time. Time is always my exponent. How do I solve for an exponent? I have to use logarithms, which you guys are experts on, okay? So how long, hey guys, I'm recording. How long would it take for the money to triple, okay? So that means I'm going to start with 4,000 as my principal. When it triples, how much money will I have? 12,000, okay? Everything else is just the same. N is equal to 12, and what is it? Time is what I don't know, and the rate is still 0.035, okay? So let's put all of that in the equation. So I've got 12,000 equal 4,000, 1 plus 0.035 over 12 raised to the 12 times t, okay? I'm solving for what? T. In order to solve for my exponent, I need the exponential term to be all by itself, okay? What is keeping that from being by itself right now?
A lot of stuff.
Well,
everything besides t. Can we use a calculator in this whole thing?
You can't. Yes, the whole test. What? Divide by 4,000. So you guys just need to settle down. Divide by 4,000. Okay. Now you can use your calculator for everything. You can do some mental math, but what is 12,000 divided by 4,000? Okay, maybe let's go to the calculator. 12,000 divided by 4,000 is 3, okay? That's an easier number to work with than this. So 3 is equal to, okay, 1 plus 0.035 over 12, all of that raised to the 12t. Okay. Let's figure out what this 0.035 over 12, let's figure out what that is. So 1 plus 0.035 divided by 12, 1.00292. No. You'll get the wrong answer. So 3 is equal to 1.0092 raised to the 12t. Okay, now, do I have an exponential isolated all by itself? An exponential term? I do. Okay, I've got 1.00. I wrote that wrong down wrong, didn't I? It's 1.00292. So 1. So it's 1.00292. Now, I need to take the log of both sides. What is the base? 1.00292 is the base. Okay, so I'm going to come over here. The log base 1.00292. Log base 1.00292 of 3 is equal to the log base 1.00292 and of 1.00292 to the 12t. Now I know that looks real complicated, but on the right side, what is the log base 1.00292 of 1.00292 to the 12t?
12t.
That is 12t. Don't spend a lot of time figuring that out, trying to solve it. That's why we took the log of 1.0292, was so that this would simplify. So now I get the log base 1.00292 29203 is equal to 12t. Trying to solve for which variable? T. What is keeping that from being a t all by itself? I need to divide by 12. Okay. So t is equal to the log base 1.0029203, and then all of that divided by 12. Anyone know that off the top of their head? So we will go to our calculator gladly on this one. Okay. So the the log base 1.00292 of 3, and then all of that divided by what? 12. Oh, all of that. What is it?
Oh gosh. You might have to do it out. Oh.
Why is it not?
Equal and then divide, maybe?
No. Let me just back up. Okay, let's do it again. Natural log 1.00292 of 3, okay, and then all of that divided by, why is this not working? Oh, no, you're not going to do it in your heads. Why am I having trouble with this? Let's just do it this way. The log base 1.00292 of 3, and then all of that divided by 12. That's fine. 31. It did it right there. It was just formatting wrong. So this is 31.4. Okay. So what does this mean? It's going to take 31.4 years to triple my investment. So this is probably the hardest part of these, okay? But I mean, the logs didn't come in until here. This is solving an equation. This is algebraic, dividing both sides by a number, okay? So there's algebra and just keeping organized to getting here, okay? Let's look at the next question, same problem. How much money would I invest today in order to have 15,000 in 9 years, okay? So what's the future amount? 15,000. How much time? 9 years. Interest rate, same thing we were dealing with, 3.5%. Okay. Compounding it how often? Same problem. Monthly, right? Okay. What is it I don't know? The initial value. That's what I'm solving for. Okay. So I use this same formula. A is equal to P 1 plus R over N to the NT. How could I solve that for P? How could I get P by itself? Well, that would give me 1 over P, but I could get rid of all that by doing what? Dividing it on both sides. Come on, guys. How do you get P by itself? Divide by all of this, okay? So P is going to be equal to A over 1 plus R over N to the NT, okay? So P equal, what is A? Yeah, 15,000 over 1 plus 0.035 over 12. And then all of that is raised to the 12 times how many years? 9 years. Okay. So that's where I go in my calculator. So let's figure that out. So it's 15,000 divided by 1 plus 0.035 divided by 12. All of that is raised to the 12 times 9 power. Okay. So this is what? 10,951.9 So this is 10,951.90 is the amount of money I needed to what? That's the amount of money I need to invest today in order to have 15,000 in 9 years. Okay? So again, you will be given the formula. The knowledge you bring to this party is what each of these elements is and how to use the calculator to solve for those. Okay? Let's look at another example. Write the specific equation that models this investment. Okay? This is compounded daily, so A is equal to P 1 plus R over N to the NT. Okay? In this particular one, what is the rate? R is what? 0.07. Okay? And now look at this question. How much money would I have in 3 years? What does a 3 represent? Which variable? Yeah, so T is equal to 3. What does the 10,000 represent? Yeah, the initial principal is 10,000. How often am I compounding this? Daily. How many times a year does that happen? 365. That means I'm going to compound it 365 times in a year. Okay? So I'm going to plug all of this in. So A is equal to 10,000. 1 plus, what did I say, 0.07 over 365 to the 365 times how many years? 3 power. Okay. So I just plug all of those in, and now it just becomes, can you type this in without getting a typo on the calculator? So it's 10,000 times 1 plus, what did I say, 0.07, was that right? 0.07 divided by 365, and then all of that is raised to the 365 times, what was it, 3 years? 3. 12, 3365. So, and this is money. So this is the amount of money that I have in 3 years. Okay. Okay. Let's move on. Next question starts with the 2 words, how long? What am I solving for? That means I'm solving for time. Time in these problems is always my what? Exponent. I'm going to have to use logarithms to make this work. Okay. So how long until my money reaches 20,000? How much did I start with? Yes. So I'm going to end up with 20,000. I started with 10,000. Okay. 1 plus, it was what, 0.07 over 365 to the 365, and I'm solving for t here. Okay. Solving for that exponent. If I'm going to solve for this, I'm hoping to get this all by itself. What is keeping it from being by itself right now? Yeah, the 10,000. Okay. So I divide everything by 10,000. What's 20,000 divided by 10,000? That's 2. So 2 is equal to, and then what I'm going to figure out what is inside these parentheses. So that 1 plus 0.07 over 365. So 1 plus 0.07 divided by 365, 1.00019. Okay. So 1.00019 to the 365t. Okay. Now I've got the exponential all isolated. What is my procedure for now solving for the exponent? After I've gotten it by itself, what do? I need to take the log. What base? 1.00019. So the log base 1.00019 of 2. Now somebody tell, what is the log base 1.0019 of 1.00019 to the 365t? 365t. You got to get to where you just know that. So when I take the log of this side, that is what allows me to solve for the variable. I want to solve for t. What's keeping this from being solved for t at this point? Yeah, so I can divide both sides by 365. So t is equal to log base 1.00019 of 2 divided by 365. If you don't know that off the top of your head, that is the log base 1.00019 of, was it 3? No, 2. 2, and then that is divided by 365. Okay, so that is what? 9.995, or really it's what, 10? You know, so this is 10. So t is equal to 10. What does that mean? It's going to take me 10 years to get to $20,000, okay, in that investment, or 10 years to double my money, okay? What I want to do now, I want to skip the last part of this problem and move on to the other formula, make sure we have time to cover it. Okay, the other formula for interest is interest that is compounded continuously. You know what it means to compound yearly. It means once a year. Monthly, 12 times a year. Daily, 365 times a year. To compound continuously means to compound at every moment in time. It's faster than every second. It's faster than every minute. It is always compounding, okay? That is this formula right here. A is equal P e to the RT, okay? The formula is a little bit easier, okay? You don't have that 1 plus R over compounding, okay? Now your key, if you ever see a problem and you see the word compounded followed by the word continuously, that is your key to use what formula? The continuous interest formula, okay? If you see compounded monthly, that's the previous formula. But anytime you see the word continuously, compounded continuously, here's your formula, okay? A is my what? It is my future amount. What is P? Yeah, that is my initial amount. What is E? It's not a variable. This is just my natural exponent, okay? It's like pi. It's a number on your calculator. What is R? Yeah, that's my interest rate, okay? That doesn't change. And remember, we have to know how to go from percent to decimal to make that work. T is what? Time in years. Okay. You would use natural log when you're solving for this one, okay? So, suppose you have an investment that pays 3.5% per year compounded continuously. How much would a $4,000 investment be worth in 30 months, okay? The formula I need to use, because I see those words compounded continuously, A equal PE to the RT, okay? What is my initial amount? $4,000, okay? Interest rate is what? It's going to be, R is going to be 0.035, okay? That's 3.5% converted to decimal. Okay, time is measured in what? Years. 30 months is how many years? Yeah, it's 2.5 years, okay, because you've got 1 year plus 1 year, that's 24. That's how you get to 30. So this is 2.5 years. And that is it. So PE to the RT. So the amount would be 4,000 e to the 0.035 times 2.5. That's how I figure out the future amount. I will go to my calculator. So that's 4,000 times, there is an exponential key right here, e to the 0.035, was it 0.035? Yeah, times 2.5, times 2.5, 4365.77. Okay, what does that mean? It means that I will have 65.77 in what, 2.5 years or 30 months. Okay, that's how much that investment will be worth in that amount of time. How much interest did I earn? Yeah, 365.77, because if I started with 4,000 and I ended up with 4365.77, I earned 365.77. Next question starts with the words how long. That means what? That means time. Time means exponent. Exponent means logarithm, okay? So how long until the money reaches 16,000? 16,000 is which value? The initial or the future? Future value. So that means 16,000 equals 4,000 e to the 0.035 t. I'm solving that for what? T. So in order to solve this, I need this to be all by itself. What must I do to start getting that by itself? Yeah, divide everything by 4,000. What is 16,000 divided by 4,000? Yeah. So 4 is equal to e to the 0.035 t. How will I solve that? I need to take a log of both sides. Which log will it be? Natural log, okay? So I will solve this by saying that the natural log of 4 is equal to the natural log of e to the 0.035 t. And you got to get to where you look at the right side. What's the natural log of e to the 0.035 t? What is it? 0.035 t. That's the reason we did this, okay? So the log of 4 is equal to 0.035 t. What is keeping me from having t equals? So I need to do what? Divide everything by what? 0.035. So t is equal to the natural log of 4 divided by 0.035. And I would do that in my head, but I don't want to embarrass you guys. So I will use my calculator. You know that I'm full of it today. Log of 4, natural log of 4 divided by 0.035 is 39.6. What does this mean in the context of my problem? Yeah, it's going to take 39.6 years to reach, what was it, $40,000. So that's a long investment, okay? Almost 40 years for that money to quadruple, okay? This next question here. How much money should you invest today in order to have 20,000 in 10 years? So it's the same continuous interest. A equal PE to the RT. The 20,000 is which value? It's A. So A is 20,000. How much time? 10 years. same interest rate, which was 0.035. What am I solving for in this equation? I'm solving for P, okay? How can I solve that equation for P? Yeah, so P is equal to what? A divided by what? E to the RT. So A over ERT is this one, okay? So just plug these numbers in. So it's 20,000 divided by E to the 0.035 times 10, and go straight to the calculator. 20,000 divided by E to the 0.035 times 10, 14,093.80. So I need to invest 14,093.80. That's the amount of money I need to invest today in order to have what? $20,000 10 years from now. Okay. So I mean, there's a lot of writing. These problems look like they're long. It's using the same problems. You just have to know how to plug in what into which equation. We've got a few. What time do we end? We've got about 10 minutes. Okay. Let's look at this one. Okay. What continuous? No, I skipped this in the last class. I'm going to skip it. So I'm going to skip it for this quiz. You've got enough to be concerned about for this.